King. He is the Director of Enterprise Services and Technologies for SpiderCloud. And SpiderCloud Wireless, I'm looking forward to hearing what he has to say about this. Come on up, Marty.
Okay, so a little bit about me. My background is I came from the enterprise side of the business and joined the small cells world mainly because I was frustrated by the inability to get signals into my buildings. So, you know, I'm kind of like the enterprise storyteller within my own organization. And I was, at my corporate HQ, I was in an interesting position because I had 40 buildings of around 150,000 square feet with a couple of outliers at $250,000 and $500,000 square feet. So I didn't fit any technology envelope as far as improvements. And with my dominant operator, I only spent like $12 million a year, which wasn't enough to justify any investment in actually improving my campus. It was big numbers to us. So a little bit about us. You know, we've been in business since 2007, and we've been shipping commercially for 3 years, and have a ton of awards. And it's just, from my perspective, as someone new to the industry, it's a pretty awesome technology. We have a huge amount of achievements behind us in patents and intellectual property, a testimony to both the engineering resources and people that we have in-house, and also the partnership with the operators to help solve some of these problems. Our portfolio ranges from 3G LTE and dual band 3G LTE with a number of different band classes available, but also dual LTE, and the radios are software upgradable. So the services node is kind of the orchestration or control point for the whole cloud of radios inside the structure, and then a single connection back to the mobile core to via security gateway, both S1 and also IUH. And this is our 310. It's the first commercially available dual mode. It runs power over Ethernet and lots of specs here, but we don't have time to talk about specs. We're going to get on to deployment. And this will be available in the show notes and information as far as posted presentations. So in the enterprise environment, it's really nice when you walk into the enterprise guy and say, I'm going to do what you understand. I'm going to take 1U of rack space in your data center, 1¼ inches. We're going to connect in the transport infrastructure from the mobile core, and I'd like to either plug into your Ethernet via VLAN, or if you have security concerns and issues, we'll go ahead and put in the Ethernet switches ourselves. So, and I say ourselves as in the operator, because we're not a services company. We sell technology that the operators install, or their mobile contractors install. We deploy on Ethernet for transport. What's good about this? This is probably the most commoditized and well-known technology on the planet in the enterprise space. Everyone kind of understands it and knows about it. Inside these buildings, you know, everyone's got an Ethernet, and the installed base that we have at this point in time is, because I track a lot of the installations, 75% of the time, the customers are saying, we from IT are so happy that you're coming to solve our problem, and we will create a VLAN for you. And in some cases, they're actually hanging and installing the radio nodes, or they're donating cable plant that they've already pulled for APs as far as Wi-Fi APs, as far as redundant cabling that they'll donate to hook up radios. So the customers are very motivated to get a signal because their business employees are saying, why doesn't my phone work? What are you going to do to fix my problem? So the business people are actually the ones that IT works for. And this for us is probably the most important piece of work that we had to do and get right as a company was a self-organizing network, so that the radios inside the building and the interactions and the mobile events as you roam around the building so you don't drop calls and so that things work correctly. In buildings that have atriums and buildings that have very interesting structures, sometimes when you're walking along your mobility event, you're handing to a radio upstairs and then to a radio on the floor you're on, and you may be handing to a radio in the lobby when you hit the third floor, rail that can see down into the lobby area. So we had to do a lot of work to get all this squared away and function correctly, because it's key to not only the installation process, but also the getting good KPIs and customer satisfaction out of the operator community. This is a dump from a system in Europe. There's 48 radios in this building, and this is actually a visualization of a SON topology table that the system uses to manage handover, so the UEs know who to hand over next to. And this is something that is, this type of setup is not possible without SON. You couldn't manually tune a bunch of radios to actually make this happen. It has to happen via software, the assignment of the PCIs and the PSCs, all, both for the UMTS and LTE, all the different channel assignments. It all has to happen kind of iteratively, but automatically. And this type of setup is anywhere from 35 minutes to an hour, depending on the size of the building. And the customer was very satisfied with this because it was a complex installation. It was a manufacturing building that was rife with tanks and metal and a lot of extremely hard to solve materials for an RF environment. And you can see at the very bottom there, the red one's 6193 GSM. That's the hand-in, hand-out candidate for the network. So the SON infrastructure actually learns about the whole outside world and sets itself up both on the interior and also its relationships with the outside world. So, in the past, there was a ton of work to do to commission the system, and one of our fundamental tenets was to simplify things and change the process so that the operators could accelerate a way to resolve and satisfy their customer requirements. So we're looking at these types of systems being able to knock out a number of steps, because the enterprise is inviting you in. You're going to light the whole facility that they've leased, or you're going to light a segment of the facility, but right in their infrastructure, be self-contained to service their needs and not kind of try and service the whole building. So, in the multi-tenant situation, our operators are basically working to satisfy the customer in the building and not so much satisfy the building, if you know what I mean. And, we're looking at times like this, so 1 month. Now this requires, process changes and a way to completely rethink things. And if you've heard some of the speakers from the operators talk, a lot of the barriers to small cells has been processes have yet to change, because we're still in the very early days of small cells. So people they're doing pilot implementations, but the process needs to be rethought from the ground up to actually get the full benefit of what you're doing. So one of our operators basically said, we need a way to disqualify installations before we invest any money. So we put a tool together so that a sales rep or an RF market engineer can do a takeoff and basically say, it's going to take this many radios to satisfy the building. On the back of this tool is a full RF calculator. But what we needed to do is make it approachable so that someone could basically run the numbers and run it through business development and say, go, no go on the implementation. The reason the complaints came about is because they said, it's $9,000 in 2 months before and a design cycle before we decide whether or not we're going to improve the building. So they were losing market RF engineer time in the market to do the design and take off, and then run it against the amount of lines the customer had, and then throw it out. So that they wanted to be able to essentially have a screening process. So this is an IB Wave. This is kind of before IB Wave in a business development side of things. And then this is a typical kind of IB Wave, a desktop design before it goes into construction. And the lessons that we've learned that probably everyone in the Wi-Fi world has learned. If you notice, no radios above people. People get very nervous to have radios above them, and it's human nature. And so one of our big takeaways was it was something that you don't know. The Wi-Fi guys know you don't put an AP right above a person because they're going to complain if they get headaches or something that the AP is doing this to me. Tell me it ain't true, Andy. So one of our takeaways was installation, installing corridors, install above shared spaces and keep it away from people. And then a couple of enterprise examples. So this is a government building. This was an interesting building because it had a lot of RF issues because it was built in the 60s and it had a lot of bomb-proof blast protection material, blast protection glass in it, so that the building couldn't get hit by an attacker. And they had to deliver a signal from the inside. There was just no way to get it in from the outside or push it into the building because of the protective techniques that had to be applied to it. And one of the most important things here was they were able to get it up in days, and the individuals that worked in this building, most of them were transient and relied on their mobiles. So when they were in the building, when they had no signal, they were literally out of touch with their job. It's a financial organization. This one was one of our first installations, and it was a mission-critical installation because the CIO said, "You've told me 9 months to put in technology. I want this resolved by the end of the week, or I'm moving to an alternate carrier that has already proven that the phones work in the building." And our engineers rushed in, helped install this and bring it up, and the sales leadership and the operator had the juice to get a transmission line by the end of the week, which for anyone here who's ordered a transmission line and had to get one, that's pretty remarkable to get a transmission line in a short period of time. But when you talk process changes, one of the things that the operators are thinking about that are doing the small cell technology, that have terrestrial assets, they're thinking about retooling MPLS processes to be able to turn up a VRF far faster than it is today, because you've already got the fiber delivered, you've already got the router and the transmission line delivered, and it's really more of a configuration of just a VRF and MPLS infrastructure. So, and then you can see from the KPIs, this one pulls 1,700 voice calls a day and 287,000 data sessions. The data sessions always, they're 10, 15, 20 times as high as the voice sessions, just because of all the apps on people's devices and are constantly talking. Cool. And then this was an interesting one, because when we talk Cloud RAN, this isn't, obviously it's not Cloud RAN, but the customer basically said, I have 3 different buildings. I will allow you to put a services node in one building, but I've got no IT telecom closets in the other 2 buildings, and I just want you to remote all the radios, and I want you to use my backbone, my gig Ethernet infrastructure, and just deliver 2 other clouds of radios in the city, so that he could centralize everything in his telecom data center. So this one was a very brilliant installation because it proved that the radios could be remoted away from the services node And as long as you have high quality bandwidth between the radios and the services node, you don't have to have a services node on the premise. So this was a very much a breakthrough installation, because you have people considering, how do I put a services node in the cloud, and how do I potentially take any of the enterprise services I'm going to deliver to the customer and run those enterprise services in the enterprise data center, where a lot of the customer's resources are consolidated and centralized. So we think this is a very significant long-term installation kind of template. And then for us, beyond coverage and capacity, we're working on quite a bit of services with the operator community to figure out how to take things to production, to enable the operators to have a tighter relationship with the customer. A lot of the enterprise services, it creates a loyalty and a stickiness that devices and SIMs just don't buy at this point in time. It's very easy to port now when you have an iPhone or an Android, to shift from operator to operator. So there's a move in the operator community to add some additional services in the infrastructure, so that the customers themselves, the subscribers, it's much more sticky, and it makes more sense to stay with their present operator versus churning around from operator to operator. And for us, the various edge cloud services, in MDM cloud with somebody like an SAP, mobile PBX and context-aware services are all extremely interesting to the operator community, as is IoT infrastructure, where you want to terminate IoT traffic inside a building and localize a lot of the traffic in the infrastructure instead of hauling it back to a cloud data center somewhere. Our platform ships with a Intel x86 Xeon processor on board, and it's got a hypervisor, and we expose APIs so you can get to the signaling and error channels and the event flow coming off the platform. So event flow is important for things like location-based services and that kind of thing, where the UE's location is being triangulated amongst the radios. And our use cases developed with our partners have been the location services, mobile UC, content acceleration to just improve the QoE and protect the backhaul from a lot of the repeat objects that you tend to see in an office building. People tend to, you get all the kind of CSS and JavaScript, the same kind of page frames. If everyone's going to Google, if everyone's going to different services, they tend to all do a lot of repeating content on the infrastructure. And then just usage analytics. So, what's interesting here is, because everything's encrypted with IPsec, you need to expose into a virtual machine via deep packet inspection a way to actually see analytics in the infrastructure and be able to measure and see the customer information. If I'm plugged into just an SFP looking IPsec, all I see is a giant pipe going back towards the mobile core. I can't differentiate any of the traffic in there because it's all opaqued. So with everything being opaque from a privacy and security perspective, analytics have to be done by having an installed application that can actually break it down and be like a software probe. And this is the caching app that we've worked with Intel on, and it does DNS, content caching, and also does quite a bit of the frequent policy updates and stuff that the enterprises might want. This is something that was built with McAfee to allow bump-in-the-wire inspection of content traffic. So the use case that came up from the operator community was, my customer is concerned about legal liability. They're going to invest and pay money to improve small cells, but they have a duty to protect other employees from the content that some person might be browsing on. You know, if I look over the shoulder and see something bad, I can sue. You know? And so what they're saying is, if I've improved it, I want to have a duty to potentially sell a policy mechanism to the actual enterprise to allow them to control the RF only in that building. It's you know, and then give them essentially a portal in the center that potentially connects back to the McAfee console that the enterprise is already running for all their server infrastructure, such that it can just be run as part of the overall enterprise machine and not be yet another thing to be managed that's separate away from the enterprise. So this one is very, very interesting from a security and compliance perspective. And then, you know, location and asset tracking, and this is just using standard, you know, triangulation amongst the UVs. And then, you know, finding people, finding resources. You know, and this kind of system looks very much like instant messaging, where you opt in and like you will buddy list and that kind of thing. So you can only track your friends or people that have allowed you to track you. And then this is a content management example that was built with IBM. And this one is something where, like, you bought a movie ticket from Fandango. When you arrive at the theater, it knows about your movie ticket in the Fandango app, and it can push a movie trailer onto your device. And because it doesn't use any backhaul, it's very much a zero-cost event to the operators. The services kind of need to just continue to, you know, push the same content to different UEs as they arrive. And it is something that would be, you know, opted in and actually built into the app itself. And then from the stadium experience, you know, this type of thing is a very difficult problem, and it's you know, as Michael from Solid, he was talking about the difficulties of stadiums, and it's, you know, this is a challenge for all of us, and that's kind of it. What I have to talk about. Do we have time for questions?
Just a couple minutes.
Yeah, questions.
Any questions from the audience?
Yes.
Rob Randall from Sears Capital. What do you believe is the aggregate amount of bandwidth that comes out of one of your typical buildings in terms of capacity to all of the subscribers in there? You mentioned 1,700 people and you have 40-some or 60-some of these access points. How much capacity do you provide to those people, and then how much backhaul are you consuming back to the network from that building?
So the interior network inside the building is either 100 meg Ethernet or gig Ethernet, and the Ethernet trunks between the switches are either 100 or a gig.
No, I'm actually thinking about the throughput to the subscriber pulling devices. How much actual throughput, not
the backhaul tends to be sized by the amount of subscribers in the building. Generally,